Okay. The second chapter, we are going to look at motion in one dimension. Now, motion in one dimension, it means that you are moving along a straight line. You move to and fro along the straight line, go
Okay.
forward, backward. And it is not, you are not moving along the Cartesian plane, or you're not moving on the Cartesian plane where you have the X and Y coordinate. So you just move at an angle like that. It is not like that. Okay, so motion will mainly in a straight line. And motion in a straight line, normally we use a number line. Number line. Now this is a number line. Okay, this is a line with numbers starting from 0, 10, 20 until positive 60, and from negative 10 until negative 60, and so on. So we are going to use this model to represent. Now, whenever you cannot understand, you just fall back on this number line model that we are going to learn. Okay, right. So a number line indicate the position of the moving object at different time. Okay, now number line shows us the position. Now let's say, for example,
Mm.
this car A here at the position A is 30 meters from 0.
From zero. Okay.
The initial position is 30 meters. Now this 30 meters, that means it is 30 meters, positive 30 meters. It means that it is 30 to the right hand side of 0. Because now we are talking about displacement, and the meter here, the length here can be positive or negative. So if you look at the position A, it is positive 30 meters, positive 30. Now if you look at position B, it is uh, positive 50. So it means that it is 50 meters from this point, the starting, the O here. Oh, if you cannot imagine, then you think that is somebody running. You take a video of the person running, then
Mm-hmm.
you display the picture not as a moving video, but as a picture every 5 seconds. 5 seconds, then you see the person running this way. Then after another 5 seconds, you see the person in another position. So can you imagine something like that? It's like a frozen part of your video like that. After 5 seconds, you freeze it, then you put that. After 5 seconds, you show another position. Okay, so that is how we're going to look at it. Displacement is the change in position of the object. Now, what do you mean by change in position of the object? It means that initially you are at a certain position, finally you are at another position. So the difference between these two positions, or the length between these two positions, is the displacement. Now
Okay.
if it's towards the right, then you say it's a positive number, positive 10 or positive 20. The displacement is positive 10 or positive 20. But if the final position is on the left of the initial position, then the displacement will be a negative number. Okay, it will be a negative number. Now, mathematically, it is written like this. Mathematically, it is written like this. You want the displacement is delta x. Delta here represents the change. Normally in mathematics, this symbol delta means the change. Okay, change in position, change in velocity, change in speed, and so on. So the delta, the small triangle delta there, means change. In There's another way of writing the delta, no? I don't know whether you have seen another way of writing. Most of the British textbook, they use the other delta. This
Okay.
delta here. This is also called delta. Let me increase the size. Yeah, yes. This is also delta, right? Aiya. Okay. So either you use a triangle to represent delta, or sometimes you use this, oh, cannot see, this thing to represent delta, like a D like that. Actually, it's the letter D, right? Oh, so what is the displacement? One more time. Displacement is actually the change. So change in x. the change in the position x. How to get this change in the position x? Mathematically, you use the final position xf minus the initial position xj. Okay, right. Now, let's look at this example here. From A to B, what is the displacement? From A to B, what is the displacement? Okay, so let's say,
Okay.
can you tell me what is the xi, the initial position? Xi. The initial position is 30. Okay. What is the xj, the final position? It is the
60.
position, not the movement,
Oh,
not the length and so on. So what is
50?
the final position? Where is it now?
50.
50, right? So now I say the displacement from A to B, displacement from A to B is xf minus xi, 50 minus 30. So what is the number 50 minus 30? Positive,
20.
positive
20.
20, correct. Positive 20. So positive 20 means the final position is to the right of the initial position. If it is negative, then the final position is to the left of the initial position. So this time, the positive and negative sign, it does count. It does count, right? So you don't think that, oh, there's no such thing as negative in length. Yes, there is. In displacement, there is positive and negative length. Positive length means towards the right hand side. Negative length means towards the left hand side. Okay, so this is the linear model that we are talking about. Now, sometimes they will give you a graph. It is not a graph of x versus y, which is the coordinate system. It is a graph of displacement versus time. It is a graph of displacement versus time. So the vertical axis represents the displacement. The horizontal axis represents the time. Okay, right. Okay, some I typed wrongly again. I typed wrongly again and again. Okay, this is 30, eh? This is 30, eh? Hey, 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 hey. Okay, right. Okay, okay, right. So you look at this graph here. You look at the graph here. When the time is zero, when the time is zero, okay, when the time is zero, the position is 30. Time is zero, the position is 30. Is marked on this point. When the time is 10 seconds, the position from that zero is 50. Is 50 here. Okay. So we have 2 points, A and B. A means at the start, 0 second, the position is 30. It means this one. Okay. Then here, after 10 seconds, the 10 seconds is not indicated on the linear, on the number line. Okay, 10 seconds is not. After 10 seconds, the position is 50. So after 10 seconds, the position is here 50. So if I want to know the displacement, position of car A is at 30, position after 10 seconds, position B is 50. So if I want to know the displacement, the final minus the initial, final minus the initial, so it is 20 meters. And it is actually positive 20. Okay. Note that the displacement is positive 20 meters. So it means that it is 20 meters to the right of A. It means the displacement is the position, the direction from left towards the right. So the initial position is left, the final position is the right. So we look at this again. displacement and distance. Displacement is the change in position. Distance is the magnitude of the displacement. So when we talk about the distance, we just ignore the sign. So how far is A from B? Or how far is B from A? So you'll be 20 meters. There is no such thing as positive 20 or negative 20. Okay, so the distance,
Mm-hmm.
no sign, but displacement, yes. So far, any question?
No.
No. So this is about displacement. Now again, we look at another number line. Now in this number line, they have shown different positions. Position F, E, D, and C. Four different positions. And what is the time between these two positions or any two positions? I don't know. Unless I look at the position versus time graph. If the graph is not shown, I don't know the time. I only know where they are at F, E, D, and C. Okay, so I just simply take two position. Let's say position of car at C here. Position of car at C, it is 38 meters. Position of car at F, F is here. Position of car at F, and it is given negative 53 meters. Okay, now find the displacement of car A, sorry, of the car from C to F. Now you have to note, they say from C to F, C to F. Do you know which one is the initial position from C to F?
Initial position F
From C
or
to
C
F. Huh?
or C.
From C. That means you start from where?
C.
From. From C means start from C. To F means finally you arrive at F. Okay. Don't look at
Okay.
the car, the alignment of the car, whether it is moving this way or this way. Maybe the car is reversing, we don't know, right?
Okay. Okay. Okay.
So if they say the displacement of the car from C to F means the initial position is C, the final position is F. Okay. So how much is the initial position? 38, final 53. So I use the final position, negative 53
Minus the
minus
initial.
minus positive 38 minus positive 38. Okay. Right. So in the end, I get negative 91. So I say that uh, the displacement of the car from C to F is negative 91. Now I would like to draw, right, from C to F, from C to F, okay, from C to F. It is in, it is towards the left or towards the right? From
Towards the
C
left.
towards the left. Now towards the left is negative, right? Now back here from A to B, can you see the first number line? From A
Mm-hmm.
to B, right? This is from left to right or right to left?
Right
A
to left.
from
Oh, A to B is right. Left to right.
left to right, so it's moving towards the right.
Right side.
Okay, moving towards the right. This one is moving to the left. So can you know why here it is positive 20 and while here is negative 91? Can you explain why one displacement is positive and the other displacement is negative?
Because the direction difference.
The direction. Towards the right is positive, towards the left is
Mm.
negative. Okay, now we are going to look at the the symbol, the notation, how to represent this vector quantity. Displacement is a vector quantity, right? Because it has positive and
Okay.
negative. Now, displacement is a vector quantity. Negative sign indicates that the displacement from right to the left, right to
Uh,
the left. The symbol for denoting a vector quantity is like this. You have a bold letter with an arrow at the
mhm.
top. This will represent, it will represent a vector quantity. So far, any question?
No.
No, huh? So I summarize lah. What you have learned so far is displacement. Displacement is a vector quantity. It has positive direction and it also has negative direction.
Okay.
Okay. So it's either a positive length or a negative length. Okay. The next thing you need